So electric potential due to a dipole at any point. So we are considering a dipole. So plus Q and here minus Q. And we want to calculate the potential at the point P. So from the plus Q we can draw the distance as R1, and from the point P to the minus Q distance we are taking as R2, and the dipole length we can take it as 2A, and here the center we can take it here, so A and A. So from the center to the point P the distance we are taking as say R, okay, and this is the angle theta. The dipole moment direction is from negative to positive. So the dipole, it makes an angle theta with that R. Okay. So now we know that the potential at the point P due to plus Q. So we can write due to plus Q the potential is 1 by 4 pi epsilon naught into Q divided by R1. And due to minus Q it is equal to 1 by 4 pi epsilon naught into minus Q divided by R2. Okay, so what will be the total potential? We have to add this because it is a scalar quantity only. So V of plus Q plus V of minus Q. So we can represent 1 by 4 pi epsilon naught into Q into 1 by R1 minus 1 by R2. This is the potential. Now our question is you have to find what is 1 by R1 and 1 by R2. So for that purpose we can take the law of cosine. So we can take R1 square is equal to R square plus A square minus 2AR cos theta. Okay, that is the law of cosine. So from this again we can simplify R squared into 1 plus A squared by R squared minus 2A cos theta divided by R. Again you can take, if R is very large compared to A, we can neglect which one, A squared by R squared we can neglect. Okay, because R is very large compared to A. So we got the equation as R squared into 1 minus 2A cos theta divided by R, that is R1 squared. So now we have to calculate 1 by R1. So we can take 1 by R1, we can represent it as 1 by R, then 1 minus 2A cos theta by R whole to the power 1 by 2, or this can be written as 1 by R into 1 minus 2A cos theta by R whole to the power minus 1 by 2. So here we want to use the binomial expansion. So we will get 1 by R into 1 minus x to the power minus n, we can represent it as 1 plus nx. So we will get 1 plus half into 2A cos theta by R. So we will get A cos theta divided by R. So that is the value of what? 1 by R1. Similarly, we can calculate the value of 1 by R2. So there we can use R2 square is equal to R squared plus A squared minus 2AR cos theta. But here theta is equal to 180 minus theta, because this is the angle we want to take. So this angle will be 180 minus theta. This is the angle, that is 180 minus theta. So again we are coming to this point, so we can write that is equal to R squared plus A squared cos 180 minus theta, that is equal to minus cos theta. So we will get plus 2AR cos theta. Okay, so that is how much r2 square. Again we have to use the same method and we will get the value as 1 by r2 is equal to 1 by r into 1 minus a cos theta divided by r. Same method we have to follow. So 1 by r into 1 minus a cos theta by r. So we can find 1 by r1 minus 1 by r2, that is equal to 1 by r into 1 plus a cos theta by r minus 1 by r into 1 minus a cos theta divided by r. So we can simplify. This is 1 by r, this is minus 1 by r, so that will cancel. Here a cos theta by r squared minus of minus, so plus a cos theta by r squared, so we will get 2a cos theta divided by r squared. That will give us what? 1 by r1 minus 1 by r2. So we got the equation as potential is 1 by 4 pi epsilon naught into q into 1 by r1 minus 1 by r2. So you can substitute 1 by r1 minus 1 by r2 as 1 by 4 pi epsilon naught into q into, what is 1 by r1 minus 1 by r2? That is 2a cos theta by r square. So you can substitute 2a cos theta divided by r squared. And what will be the value of q into 2a? That is the dipole moment. So that is equal to p cos theta divided by 4 pi epsilon naught into r square. So this is the equation for the potential due to a dipole at any point. At any point if you are taking, you will get p cos theta by 4 pi epsilon naught into r square. Now if you are giving theta is equal to 90, that means equatorial line, then v will becomes what? P cos 90 becomes divided by 4 pi epsilon r square. So that will becomes what? 0. So along the equatorial line potential is 0. Now if you are taking theta is equal to 0 or theta is equal to 180, so you will get, if theta is equal, it is an axial line only. So axial line, this is equatorial line, and if you are finding the potential along the axial line, if it is theta is equal to 0, then we can give cos 0. So we will get p by 4 pi epsilon naught r squared, and if it is given theta is equal to 180, then cos 180 you will get what? Minus. So we can give plus or minus. Okay, that means if theta is equal to 0, you will get theta is equal to 0 means we will get plus p by 4 pi epsilon naught into r squared. Theta is equal to 180 means you will get how much? Minus p by 4 pi epsilon naught into r squared. So this is the general formula, that is v is equal to p cos theta divided by 4 pi epsilon naught into r squared.